Hi. Now let's look at rate of change of a function. Okay, means that if a function is y is equal to f of x, at x is equal to a, x is equal to a1, y is equal to f of a1. At x is equal to a2, y is equal to f of a2. Okay, so what is rate of change of function is, it is delta y by delta x. That is how with the change in x, okay, how much your y changes, how much your function changes with the change in the input. That is your rate of change of function. So rate of change of function is f of a2 minus f of a1 divided by a2 minus a. Okay. Rate of change is a very important quantity. And you know that, for example, rate of change of velocity is acceleration. Rate of change of momentum is force. So this is a very important quantity, the rate of change, and that's why we will be looking at rate of change, delta y by delta x. Let's say my function is f of x is equal to x square. Then the curve is something like this. Okay, region greater than 0. As x is increasing, your function value is also increasing. And for the region where x is less than 0, as you increasing x, the value of y is decreasing, your function is decreasing. Okay. Now, what do we mean by derivative of a function? What a derivative of a function is at a point. So derivative of a function at a point is the slope of the tangent to the curve of the function at that point. So this is the curve, then the tangent is, let's say this is the tangent. Means this is a straight line that is passing. This is a tangent. Okay, say this is a straight line. Okay. Now, derivative of a function at a point is the slope of the tangent to the curve of the function at that point. So at this point, what is the slope of this tangent? That's what the derivative is. Okay. So for derivative to exist at a point, it must have a unique tangent at that point. Like in this case, there is a unique tangent. Consider a sharp turn. Consider a cone. So at this point of the curve, let's say there is another curve. If you want to find the derivative at this point, the derivative does not exist at this point because you cannot have a unique tangent. So this is what a differentiability is. At this point, it is differentiable. At this point, this function is differentiable. At this point, this function is differentiable. At this point, this function is differentiable. But at this point, it is not differentiable. If you take a curve like this, then it is differentiable all these points, but at this point, it is not differentiable. But then at these points, it is differentiable. Okay? Just from the looks of it, what we can say is that if whenever you are having a sharp turn, a very sharp turn, a very sharp turn, then at that point, function is not differentiable. Okay, so function is differentiable. So function is differentiable if the curve is smooth. If the curve is smooth. Okay. Function is not differentiable at sharp points. Okay. Differentiability at a point a function f of x is differentiable at x is equal to a means that it is continuous at that point first, and this condition. Okay. And what is this condition? What is this actually? What is this limit? This limit will give you, if this limit exists, this limit is nothing but the slope or slope of the tangent at that point. Okay. This is how we represent it, f dash a. So if these two limits are equal, it means the limit exists, and the slope of the tangent at that point is f dash a is equal to f of a plus h minus f of a divided by h. Let me explain this. Let's take this function. Okay. So this is your x-axis, this is your y. Now, if you look at this a, and this is another point, a plus h, and this is another point, a minus h. Okay. Then what is the rate of change? What is the rate of change? Okay, in this interval, the rate of change is f of a plus h minus f of a. Okay. Divided by a plus h minus a. This is equal to f of a plus h minus f of a divided by h. The rate of change delta y by delta x is this. Delta y by delta x is this. And when you look at this, then delta y by delta x is f of a minus f of a minus h divided by a minus h. This is equal to f of a minus f of a minus h divided by. This is slope delta y by delta x. This is your delta y. This is your delta x. Okay, let's talk it. Let's say it is delta y1, delta x1. This is delta y2, delta x. And this is your delta x2, and this is your delta y2. Then delta y1 by delta x2, delta y1 by delta x2 is what? It is what? If you draw a line that meets these 2 points, okay, if you draw a line that meets these 2 points, then this is delta y by delta x2 is this tan theta, which is nothing but this means that this delta y1 by delta x1 is the slope of this line, right? Similarly, delta y2 by delta x2 is the slope of the line when you join these 2 points. Okay. Now, if you look at this limit, what we are doing is, in this limit, h is tending to 0. So, h is tending to 0 means your a plus h, and h is infinitesimally small. Okay. H is infinitesimally small positive number. H is infinitesimally small positive number. Okay, h is greater than 0, but it is infinitesimally small. So when h is greater than 0, then f plus h is a number that is very close to 1, very close to a. F a minus h is a number that is very close to a. Delta y1 by delta x2 is giving you slope of this line. This is a line that joins 2 points on your curve. That line is called secant. So this is your secant 1. Let's say this is secant 1. And this is secant 2. This is delta R2. So this is second one, this is second two. So this is nothing but slope of second one, and this is nothing but slope of second two. Slope of second one and slope of second two. And this is a smooth curve. This is a smooth curve. So when you make h tends to 0, second one and second two is the same, becomes second one and second two. As you make these points closer, the value, then these two seconds actually becomes just one line which is tangent. When it is differentiable at this point, so this happens. So when we make h tends to 0, second one and second two becomes the tangent. When we make h tends to 0, okay, then this quantity is limit h tends to 0 f a plus h minus f a by a, and this quantity is limit h tends to 0 this. And when we make h tends to 0, then what happens is that these two limits becomes equal. Means the slope becomes equal. Means the slope at this point becomes equal. This is the same line, because the point is fixed. The point is fixed, and the slope is also same. It means it's the same line, and that line is the tangent. As it becomes closer, you can visualize it, because I cannot zoom it. So as you get at this point, then this is the second, and this is the second. So it becomes, as you comes closer, it becomes one line, and that line is nothing but the tangent at this point. Okay, and the slope of the tangent is given by these two. Now when it comes to the sharp points, then these two slopes are not same. Means these two, second one and second two, they remain as two different tangent one and tangent two, and so it is not differentiable at that point. Okay, thank you very much.